Blockchain has the power to disrupt how we utilize the internet on a daily basis. But there's one big problem holding us back from massive adoption: exploits and hacks. There have been billions of dollars stolen in the last couple of years alone from exploits and hacks that have just led from simple vulnerabilities in smart contracts. In today's video, we're going to be going over one of those vulnerabilities. We're going to be going over unhandled external contract calls and how to mitigate. My name's Anthony with the Blockchain Dojo, where we turn you into a blockchain ninja. If you learned something new, please like and subscribe. Let's get started. First, we're going to get started by going over what an unhandled external contract call means. Whenever making external contract calls, there's a potential security risk where malicious code can be injected into the control flow. One way to avoid this is to not use delegated call or untrusted contracts. Also, not to use the transfer send functions when sending Ether, but instead use the call function. Another way to explain what an unhandled external contract call is it is essentially not checking when the return value is from the call to the contract. Let's say, for example, you are making a call to a contract and sending ETH over. You want to ensure that the return value of sending the ETH comes back as true, meaning that the transfer was successful. By not checking this return value, you leave your code open to malicious actors to actually inject their own code into the control flow. Also, by not checking the return values, you could potentially not be receiving the appropriate return values that you were expecting, which can lead to more vulnerabilities down the line in your code. Here's an example of the unhandled contract call vulnerability. Here you see in this bad contract that they are actually withdrawing a specific amount, and they're just using the transfer function to send the amount to the message.sender without checking what the return value is of that function. Without checking what that return value is, it could actually return back positive, or without checking what that return value is, it could return back true or false. And if your contract or the remainder of the contract relies on the return value being true, and you're unchecked and it comes back false, it could lead to further vulnerabilities. Now, for the fix in this, I do want to just state one thing, that this .call.value amount is actually deprecated and we've changed the syntax slightly. But ultimately, this fix here is how you would actually go about it, by doing a bool success to check the return value or the return boolean of the message.sender.call.value. And then you want to require that the success is true. Now, the new syntax for this would be msg.sender.call curly brackets value colon/amount, and then the remainder of it returns the same. Ultimately, what this is, or what this fix does, is it checks the return value to ensure that the tokens were in fact transferred out successfully. That is one example of an unhandled external contract call and how to actually mitigate it. Ultimately, what I was trying to portray in this tutorial is that you need to check your return values. If a function returns a Boolean, true or false, you should be checking that in every call to your contract, that the return value is indeed correct. If you learned something new, please like and subscribe, and stay tuned for more content.